Join us on an investigative journey as we educate each other on a scientific discovery, concept, or phenomenon.
Then we'll take a dive into the complicated and misleading world of pseudoscience to sort the factual from the fabricated.
I'm Matt McCabe.
And I'm Levi Bateman.
And this is IdioFacto.
Alright, so we're back. This is episode 2 of IdioFacto, and we liked recording the first one so much that we've decided to come back and do it a second time, and hopefully a third, and to infinity and beyond, I suppose.
Yeah, well, I guess we'll see how we go. Today, we're doing pretty much the same thing. Levi will talk about a science topic, which this week is...
I'm going to be talking about the Large Hadron Collider.
And I'll then take you through anti-vaccination, which is quite a big topic, and we could probably have 3 or 4 episodes just on anti-vax by itself.
I can't wait to learn about this.
Well, it's pretty detailed, so we'll have to give it some attention that it deserves, but there's a lot more information out there. There'll be a lot of papers and articles in the show notes for you to go and have a look at after you've finished listening, because this is a huge topic and we'll only basically skim the surface, but hopefully give you a good enough perspective of the pseudoscience that surrounds vaccinations and what you should start to look for.
That's right. And I think it's probably what, in general, is going to happen with this show. We're not going to be able to cover each topic in depth. I mean, firstly, because we're not experts.
Far from it, in fact.
We like to think that we are sometimes, but believe it or not, we are not experts. And also, we just don't have time. Most of this, what we're going to be talking about, comprises of decades of work. So we're just going to skim the surface, essentially, talk about the interesting parts, and give you enough information that you might be interested in it and go and do some of your own research.
Yeah, and I guess that's what we encourage everyone to do as well, is definitely do your own research and don't take anything that we say as the absolute truth.
No, please do not. We should probably add some kind of disclaimer.
Yeah, probably. Well, this is it. This is your disclaimer.
That's right.
So don't take everything that we say as absolute fact, because we make mistakes. We're only human. And although we do plenty of research and hope that we get everything right, we're not going to be realistically able to give you a full picture in a 45-minute podcast.
That's right. All right, so I guess I'll get into the topic that I'm going to be discussing this week. I'm going to be talking about the Large Hadron Collider.
When you suggested doing this, I was really interested because I know nothing about physics, and especially not about the collider.
Right. Physics is another field that I did a little bit at school. By university level, I was not doing any physics at all, but I've just always been fairly interested in it.
Kept up the interest post-school.
That's right. And the Large Hadron Collider is the biggest physics experiment to exist as of February 2019.
Physically or?
Physically, yeah. Yeah, it actually is. And in terms of significance as well. It's very significant. And in terms of cost and people involved. So I was doing some research on this, and I was wondering how to introduce the Large Hadron Collider. I thought this would be easy. I don't know why. I was going to start by just basically talking about what a particle is. And I've realized, surprisingly, particle physics is incredibly complicating.
No way.
It is so complicated.
I never would have known.
Yeah, I sort of started to read all these words.
I guess it's a bit off-putting for most people when you throw out words like quantum and particle and quarks.
Yeah, exactly. So I sort of delved deeper and deeper, and each time I thought I'd found the end of it, I found that particular particle was made up of a smaller subatomic particle. But
that's kind of the nature of these sorts of physics experiments, isn't it? It's to try and find the fundamental particle, the smallest thing that there is, basically, isn't that?
Kind of. In basic chemistry, we're taught that there are 3 types of particles. We're taught that there's an electron cloud that revolves around a nucleus, and so that you've got the electrons buzzing around the outside. Then the nucleus is made up of protons and neutrons. This is true, but these are not the smallest fundamental particles. For example, a proton is made up of 2 different types of quarks. So a quark is believed to be sort of the most fundamental particle in physics. But you've got fermions, quarks, leptons, you've got mass particles, and you've got energy particles. So the energy particles are the Higgs particle, the photon, the gluon. Then you've got the neutral weak boson, a charge weak boson. 6 different types of quark. So get this, the different variations of quark are called flavors,
Nice.
which is awesome. So the 6 flavors of quark.
I'll take a salted caramel, thank you.
Almost. They're almost as cool. We've got up and down quarks. We've got strange quarks, charm quarks, and then bottom and top quarks.
Oh my god. It sounds like somebody's made this up as a movie.
They're having a laugh, right? And then supersymmetry gets even more silly. So basically it just adds an S to the start of each of these particles. So a quark is called a squark. A strange quark is called a strange squark. It's a slepton, selectron for an electron, sneutrino, smuons. It gets a little bit ridiculous, but
You're making this up, surely. There's no way this is a legit
I'm
thing.
not making it up, but somebody did.
Well, obviously.
Yeah. Essentially, you've got up quarks and down quarks that make up protons and neutrons. Electrons are their own particle. Nothing makes up an electron. Oh, well, an electron makes up an electron. And then you've got neutrinos. And so the sun makes neutrinos by the millions. They don't really interact with anything. They just pass straight through us, straight through Earth. They're almost undetectable. If you want to know more about these particles, I watched a fantastic documentary called Beyond the Higgs, What's Next for the Large Hadron Collider. It's a lecture given by a particle physicist called Harry Cliff, and he does a really great job, better than I could, of explaining what all these subatomic particles are.
Okay, I'll be putting that one on my list.
Absolutely. Yeah, everyone should go watch it.
Because basically what you just said to me before when you were naming the particles, it just sounded like you were making up
It sounds
words.
really silly.
Mm-hmm.
So the particle probably that we're most concerned with today is a hadron.
So a hadron is actually a particle.
A hadron is the name given to a particle that consists of 2 or more quarks held together with strong forces. So
Any particular type flavor of quark?
any 2 flavors put together. So not all of these flavors of quark exist at the same generation of matter. So there's generations of matter, which I didn't know. Most of the higher generations of matter actually decay very, very quickly, and we'll never see them. We can't really detect them. They're produced in some sort of high energy reaction, and then they just decay quickly, very quickly, into hadrons or electrons or neutrinos. They decay. So we don't really ever see them. So probably the most commonly known examples of a hadron is a proton and a neutron. These are the big particles that make up the nucleus of every atom. At the center of every atom is a proton, at least one proton, and in all cases except hydrogen, there is also a neutron. A hydrogen being just a single proton and a single electron. This can all be found if you look at a diagram of the Standard Model. It's very complicated, and only after hours of scaring YouTube and the internet did I find a good explanation of what the Standard Model was and what the different columns and rows meant. But it kind of looks like the periodic table, but for subatomic particles. So yeah, there's these mass particles and energy particles. And the energy particles are the photons, gluons, which literally are acting kind of like glue. And then you've got these W and Z bosons. So all of this just to say that it's really complicated and there's a lot of different particles. Essentially, the Standard Model is made up of 16 different types of particles, mass and energy particles. And there was one particle that we hadn't yet discovered, we hadn't yet observed, but it was theorized in 1964 by this guy called Peter Higgs that it must have existed, that this field of these particles must have existed because all of the maths couldn't account for what was happening without this Higgs field. So it was theorized sort of over 50 years ago, but obviously in 1964 the technology wasn't fantastic. So there were basic cyclotrons, but nothing to the scale of the Large Hadron Collider.
So a cyclotron is just a primitive small collider, basically.
That's right, yeah. And usually in a lab above ground, and you could kind of walk around it within a matter of, minutes.
That's still pretty big.
Yeah. These things can get huge, as we'll find out how big the Large Hadron Collider is.
I'm guessing large.
It's large. Yeah. How'd you guess?
I'm guessing it's a large collider of hadrons.
Yep. Nailed it. Do you want to talk about it you take it from here?
It's probably best if you do it. Look, I don't want to seem like a smartass.
Okay, all right. So basically, the work to put together the Large Hadron Collider, it wasn't just this Higgs field that they were trying to discover. It was everything. It was basically what's in the universe. What have we got? And what makes us up? And how is it all put together? And we needed a better way to go about it. CERN are the organisation that are responsible for the Large Hadron Collider.
So what does that stand for?
It's an acronym for a French word.
How's your French?
Conseil Européen pour la Recherche Nucléaire.
Ah, awful, I see.
Which means basically European Organisation for Nuclear Research. So it was founded in 1954. The headquarters are at the Franco-Swiss border, right near Geneva. Their mission, and this is a pretty cool quote from their website. Our work helps to uncover what the universe is made of and how it works. We do this by providing a unique range of particle accelerator facilities to researchers to advance the boundaries of human knowledge, which is really what they're doing. They're right on the forefront and they're pushing research to its absolute limits. And most of this stuff, this is where discoveries are being made in the physics world. It's not in a lab anywhere else. It's at CERN. And then there's of course, a lot of work that's being done outside of this, but this is where the experiment is essentially taking place. So what they're trying to do is they're trying to recreate the conditions in the universe 10 to the minus 12 seconds after the Big Bang. During this time, all of these different mass and energy particles hadn't formed into what we now know as atoms. They were still sort of just floating around. There were gluons floating around, there were photons and bosons and quarks just floating around in this kind of field.
But presumably they didn't last for very long just by themselves.
No, not at all. And this is why most of them aren't around today.
In their primitive forms.
That's right. They're still there, and what we can do is we can make them. And so this is what the Large Hadron Collider is trying to do, is to make these particles that don't exist outside of these high energy reactions. Basically, what was theorized in 1964 was this guy called Peter Higgs and his team theorized that there was this invisible energy field, and it got switched on just straight after the Big Bang, and it existed everywhere in the universe. It's just like a grid of, it's a field. And apparently, and I learnt this just today, apparently everything exists in fields, and all particles, particle is actually not a great name for it. Apparently, each of these subatomic particles is not necessarily a particle as such floating through space, but it's a slight ripple in that particle's given field. So, there's an electron field, and each electron is basically a ripple in energy in that given field.
I think that's the most interesting thing about our model of an atom to me, is that, you see the model of the nucleus of the atom and a bunch of rings of electrons rotating around that. But that's actually not really how it works.
No.
It's a field of electrons that exists around the nucleus.
It's very slight energy changes that are occurring. And this is the thing. An electron is not a negatively charged ping pong ball. Itself is energy, as is every other particle.
The problem with physics on a level this tiny is that they are concepts that we are completely unfamiliar with as a species. The level that these things are operating on is so fundamental that it's impossible for us to comprehend fully how small these interactions are and how complicated the structure of these things are. So we're used to things being macro, so we can look and touch and they feel solid, but those things are actually made up of particles that have so much space in between them that they're effectively just nothing. But the field is the thing that we feel. The energy is the thing that we're actually touching when we touch a solid object.
Exactly. It's that it feels like touch. It's actually repulsion. So the Higgs boson field in particular, it was theorized that this field is what gives particles their mass. Particles themselves don't necessarily have mass, but as they interact with this, as they move about the Higgs boson field, the Higgs field will react with these particles and it will give them the property that we know as mass. Without the Higgs field, things would be very different. Nothing would have mass. Essentially nothing would exist. For the standard model to make sense, and for the fact that particles have a mass to make sense, this Higgs field had to have existed. And Higgs, when he first came up with this equation, and he sent it to a journal in 1964, and they basically screwed it up and threw it in the bin, and they said, "This is ridiculous. You've not proven that this is real. This is some pretty cool maths. We get that. but this doesn't make any sense. So he revised it, and he essentially just added one or two sentences, just a small part to it. And all he said was, if this is true, then a Higgs particle would be able to be detected in a particle accelerator, in a collider. And they accepted that. They said, well, if that's true...
I mean, that's a testable hypothesis, isn't it? So that's converted it from just an idea to something that can actually be tested and attempted to be disproved.
That's right. They said, let's do it then. Let's test this, because if this is true, this particle changes everything, and it's a massive breakthrough for the physics world. So the way that you can bring this Higgs boson particle out of hiding, if you will, is by causing these massive collisions. And when I say massive, I'm talking...
fundamental particle that's...
Yeah, these are subatomic particles smashing against each other, but they're very, very high energy. And the collision will cause a ripple in the Higgs field. And when that ripple comes out, if the ripple is strong enough, a little Higgs boson particle will pop out. And that's when you've got to try and detect it. You have to try and detect it as it's being produced, because it decays very, very quickly. So you need a machine that's going to smash these particles together. That's how the Large Hadron Collider came to be. Construction began in 1998 and it was completed in 2008. So as I said, it's in Switzerland. It's just under the Swiss and French border, just outside of Geneva. So it's about 100 meters underground, this giant ring. It's a 27-kilometer loop.
27 kilometers.
27 kilometers is the largest of the loops.
So that's the circumference is 27 kilometers.
That's right.
Wow.
Yeah, it's an enormous machine, and there are some physicists that say that this is probably the biggest machine that humans have ever built, and it's certainly the largest in terms of mass and physical size experiment.
So what's the diameter of a loop of that circumference?
About 8.5 kilometers across this loop, which is massive. And this is the reason that they had to put it underground. It's not because it's a dangerous experiment that needs to be kept away from the general public. It's just because it would be very, very expensive, especially in that part of Switzerland.
Well, that depends if you believe the conspiracy theories or not.
That's right, Illuminati confirmed.
That's a different story altogether.
Yeah, no, it's just because they couldn't afford the real estate, essentially. They did, however, have a 7.5 billion euro budget, which is about $10 billion US.
I see what you mean when you say that it's the biggest science experiment in the history of humanity.
That's
basically.
right. Nothing comes close. This is enormous. I mean, some space exploration probably comes close in terms of significance and cost, but this is enormous. $10 billion US, and that was in 2008. So yeah. So what the accelerator is, it consists of several smaller loops. So it spins up in all of these different loops. So it starts at a small loop. It gains speed, it's passed into this superproton synchrotron, it gains even more speed, and then eventually it's passed into this big loop. How this Hadron Collider increases this, speeds up these particles, it's just essentially it's a big bottle of hydrogen. There's a charge applied to it, so the electrons are ripped off the hydrogen, so you're just left with protons. The protons are zapped down into a tube, and then in this tube there's all of these superconducting magnets. And they exert this huge force onto these particles, which gets the particles spinning faster and faster and faster, just due to this magnetic force. But these superconducting magnets have to be very, very cold to work. So they're working at just under 2 degrees above absolute zero, which is minus 271 degrees Celsius.
That's what they're very, very cold.
That's right. It's almost as cold as you can get. I mean, the theoretical coldest temperature that we can reach in this universe is minus 273 degrees Celsius, being absolute zero, or 0 Kelvin. So they get down to this temperature using liquid helium. And this cools the whole system, and it cools the magnets down to this very, very low temperature so that they can actually work. And then they get these protons zooming down the track. So the proton, they call it a beam. The proton beam, there's billions of protons in each beam, and the beam is about 30 centimeters long, and it's about 1 millimeter thick. And within that beam, there's billions and billions of protons. And they're moving at 99.99% the speed of light. So to move this fast and to not suffer any friction or collisions within the actual chamber itself,
has to be a vacuum.
Yes, there's a very powerful vacuum. So there's so much going on here. This is such a feat of human engineering.
It's amazing that we can actually accelerate something to nearly the speed of light.
Yeah, exactly. We can't, I mean, space flight is only...
fractions of a speed.
Yeah, I mean, even you consider that satellites move at 17,000 kilometers per hour, and that's just a fraction of the speed of light. So it's very impressive that we can actually, here on Earth, using magnets, accelerate a particle to 99 it's something like 99.999991% the speed of light. So it's just off it.
But when you're talking numbers that big, being just off it is actually still a huge amount.
Yeah, you're right. Physically, it's a fair way off it. So what happens is you've got one beam traveling in a clockwise direction. You've got another beam, hydrogen atoms or protons, traveling in the other direction, and they travel around the loop, not touching each other, and their paths cross inside these collision sites. And inside this site, essentially, is where these collisions take place. So you're smashing these groups of particles together. So while you've got a beam that's full of billions and billions of hydrogen atoms, billions and billions of protons, not all of those billions of protons are actually hitting each other. Only some of them. And I saw there was one documentary that I watched that compared it to two people standing 10 kilometers away from each other, trying to fire a needle-thin arrow at each other and make the arrow hit in midair.
Right. But if you have hundreds of thousands of arrows...
Exactly. If you've got billions of arrows, chances are one of them's going to hit. And if you do it enough times, one of them or two of them will eventually collide together. That's the theory behind it. You need a lot of protons, and some of them will hit. But it's still millions of times per second. And then so what happens is the particles collide and they get obliterated, and they give off energy, they give off these massive particles, they give off quarks and gluons, and everything sort of goes flying around in this chamber. And as it passes through the chamber, as it passes through different materials inside this chamber, this is a very basic way of putting it, but each of these chambers is like a big camera that's capable of taking a picture of the collision. So you get these really fantastic, nice big 3D drawings, literally, of the collision, and you can see the trail of the electron, you can see the trail of the quark as it's whizzing out. Look it up. Go and look up Large Hadron Collider collision diagram. It's actually fascinating. They use these collision sites to measure what kind of particles are coming out of the collision, so what a subatomic particle is made of, and then also they're actually producing these particles that don't exist otherwise. So what they were searching for, the Higgs boson, basically how this is getting produced is, like I said before, you're causing this massive energy, this high energy collision, which causes a ripple in the Higgs field. Well, they thought it would cause a ripple in this theorized Higgs field. And what would happen then is a Higgs particle would get released. But Higgs bosons decay. They decay very, very quickly, and they would never even reach the detector. But what they decay into is photons. So as they're zooming off, they decay into photons, and then those photons are what you can measure. They whiz off in different directions, these photons, and you can measure the energy of each photon, and then take it back, add those energies together, and if it comes up as an energy that you haven't observed before, it must be this unknown particle. And that's essentially what they did. It's kind of like, I heard it described as blowing up a car and then trying to work out what type of car it is by watching the pieces fly past you.
Right.
So you're not getting a look at the actual car itself.
You take a photo of the pieces as they're flying past you, basically.
And you can go, hey, I reckon that particle comes off the door off a Hadron Commodore, or that's the photon from a Higgs boson. So that's essentially what they were trying to do. And on the 4th of July 2012, at CERN, they announced that they had discovered this Higgs boson. for the first time ever, this was a huge discovery, and this was one of the biggest discoveries in the physics world for years and years. And what was fantastic was that Peter Higgs and the surviving members of his team were actually in the room at the time.
Wow.
That scientists from this ATLAS experiment and this CMS experiment announced that they had both detected the Higgs boson particle.
Imagine being the man who did the maths and thought, hey, this might make sense. I wish there was a way of testing this, and took it to his colleagues and was laughed at. I guess eventually he was taken seriously, but imagine being laughed at when you first suggested it and then being vindicated 50 years later.
Exactly. 50 years later, yeah, nearly 50 years later, it was, you can imagine how amazing.
I feel vindicated when I win an argument after looking it up on Google 2 minutes later.
Yeah, this is the ultimate argument win, isn't it?
Yeah.
And a very expensive one. Oh, I can never afford to win an argument like that.
Yeah. Don't have a spare billions and billions of dollars?
I wish I did. 7.5 billion euros. I don't know if I'd build a Large Hadron Collider with my billions of euros, but
That's just selfish, Levi.
yeah, I'm sorry. So basically, this was the last piece of the standard model to be detected and proved. Everything else we could account for. We couldn't account for the Higgs boson until July of 2012. So what else has been happening at CERN, at the Large Hadron Collider, after this discovery?
It's useless and they've shut it down.
Yeah, parted out. No, they had a 2-year break in 2013 to 2015 to upgrade it to produce even higher energy collisions. Why do they want to make higher energy collisions? Well, basically, there's still so much that we don't know. Essentially, there's this dark matter and dark energy that we can't yet account for.
That is a whole nother can of worms, that dark energy, dark matter. Maybe we'll do another episode on dark matter and dark energy at some stage, because that's a really interesting concept. It's cold, it's dark, so we can't observe it through any of the means that we currently have to observe the universe.
That's right, which is possibly one of the next ventures for the Large Hadron Collider or for CERN. So yeah, so this is pretty exciting. It's very complicated, and this upgrade is probably not going to be finished until 2026. So it's still a little while away, but there's more exciting things to come, and from CERN and from particle physics, and this is something that I think and I hope that we're going to be hearing more about in the news, in the science world, as we continue.
Okay, so this week I'm going to talk to you about anti-vaccination, or the issues that surround vaccines in modern society, particularly in the first world. In particular, I'm going to talk about the MMR vaccine. So that's the vaccine for measles, mumps, and rubella. Measles, mumps, and rubella are nearly unheard of in modern Western society.
Which is a massive achievement.
Yeah, so in 2014, the World Health Organization announced that measles had been eliminated in Australia, Macau, Mongolia, and the Republic of Korea. Prior to widespread vaccination in 1980, globally, measles caused an estimated 2.6 million deaths each year.
Wow.
So that's a lot of people who have been saved by vaccines.
Yeah, that's incredible.
And they've been around since the 1980s. However, in the United States, as of February 6 in Clark County, Washington, in America's Pacific Northwest, there are 50 confirmed cases of measles currently.
Right, why is it coming back?
In the Pacific Northwest, particularly in this county in Washington, only 76.5% of children under 5 are vaccinated against measles. Part of the population is unvaccinated for religious reasons.
What religions don't promote vaccination?
Predominantly Jewish, but there's a number of reasons why religions would object to vaccinations. But I won't go into those now, because the majority of people who are not vaccinated because of the scaremongering that surrounds autism, which has been purported to be related to vaccinations.
Okay.
So The story is that kids get vaccinated and within a couple of weeks of being vaccinated, or they begin to show signs of autism.
Is autism the main scare that these communities have?
Yes.
Okay, so was there a starting point? Was there a case where a child got autism?
Yes, there is. In 1998, there was a paper published in The Lancet, which is a fairly reputable journal in the UK, that claimed that there was a link between autism and the MMR vaccine.
Right, this was in a medical journal.
Yes, it's published by a guy named Andrew Wakefield and 11 other authors. It was a case series of 12 children, all of whom had autism, and all of whom allegedly developed signs of both autism and some form of inflammatory bowel disease within a short period of receiving the MMR vaccine. So this guy, Andrew Wakefield, is a piece of work, I'll put it mildly. In 2004, an investigation by a reporter named Brian Deere identified undisclosed financial conflicts of interest on Wakefield's part. Following that, most of his co-authors withdrew their support for the study. He was being paid by lawyers representing parents of children who believed that their children had developed autism.
Really?
After being given the vaccinations.
Wow, so this is fact.
This is fact. He was being paid by lawyers representing the kids who got autism apparently from the vaccine while he was authoring the study.
Was he manipulating the scientific design to skew the results?
In 2010, there was a statutory tribunal that found him guilty on 36 charges.
Wow.
Including elements of falsification in the manuscript itself and undisclosed financial conflicts of interest, as well as not acting in his patient's best interests, and 12 counts involving the abuse of the developmentally delayed children. So performing unnecessary invasive medical procedures like colonoscopies and lumbar punctures. So in 2010, he was stripped of his ability to practice medicine in the UK, and The Lancet issued a full retraction of the paper, at which point all of the co-authors also withdrew their support.
Right, okay. Does the paper live on? Have you been able to find it somewhere?
It does live on. It's been retracted and is worthless, effectively.
Yeah, right. I'm just wondering if it's ever used as a source in anti-vaxxers' arguments.
Often used.
Okay.
The argument is that it's being repressed by the pharmaceutical industry.
Ah, okay.
Which there's no evidence for whatsoever. By the stage that he was struck off the UK Medical Register, Andrew Wakefield was already living in the US and had already been preaching his anti-vaccination agenda for many years. And that sort of caught on to the nascent anti-vaccination movement that was already starting due to the concern about thimerosal, which is a mercury-based preservative in vaccines at the time. We'll move on to thimerosal a bit later, but I want to start with an interview that Andrew Wakefield gave just prior to the release of his documentary, using the word documentary loosely, called Vaxxed, which is basically a piece of anti-vaccination propaganda.
Great.
I'll put a link in the show notes to this, but I'm hesitant to give this channel any more views than it does, given that it's heavily anti-vax.
I'm guessing you didn't pay this guy to watch his documentary.
I did not pay this guy to watch his documentary. I refused. The only way I could find a copy was to pay for it, and I refused. I have read several critiques of it, and we'll get to why it's hardly worth proper response anyway.
What happened was in 1995, parents started contacting me saying my child was developing perfectly normally. They had their MMR vaccine on time, and then they became very drowsy, they started screaming, they slept for days, and they were never the same again. All of the skills they'd acquired disappeared. Their speech, language, interaction with their siblings all went. And they were ultimately diagnosed with autism.
The first issue is that correlation does not imply causation. That's one of the most basic logical fallacies that exists.
Big time.
Just because you receiving an MMR vaccine coincides with you exhibiting symptoms of autism does not mean that the MMR vaccine is the thing that caused the autism.
No, that's right. And I guess this guy, Andrew Wakefield, would have started to, and his supporters would have started to build up a confirmation bias, because I'm guessing the MMR vaccine wasn't uncommon. So children that were being brought in with autism, a question would have been asked, have they had the MMR vaccination? Yes. Well, this must be the cause.
The thing was, the parents had come to him to begin with concerns about the vaccine, thinking that because they were vaccinated, then they started exhibiting these symptoms, that it was the vaccine that must have done it. So they came to him with the proposal already that it was the vaccine that was the problem.
Oh, right. A self-diagnosis.
When do you think the MMR vaccine is given? At what age?
I don't know. I'm gonna go 3 months.
There's one round given between 9 and 15 months, and there's another one a bit later than that.
Okay.
What age do you think that children start to display symptoms of autism?
About 4 or 5?
Between 12 months and 2 years.
Oh, really? You can detect it that young?
Yep. Which is about the same time as they're getting their vaccines.
Okay.
So it's a coincidence MMR vaccine was given at the same time as the autism symptoms started.
Right, but those timelines are...
They're independent.
Too perfect if you're trying to confirm that hypothesis.
Even if you're not given the vaccine, if you're not vaccinated, but you are autistic, you will most likely start to exhibit those symptoms between the ages of 12 months and 24 months. If you are vaccinated, you are most likely given those vaccines between 9 months and 24 months, which is about the same time.
Yeah.
So whether or not these children were given the vaccine, they may have begun to exhibit the symptoms of autism regardless.
Yeah.
And they had come to me because their children had unexplained gastrointestinal symptoms, diarrhea, constipation, failure to thrive, abdominal distension, pain. They couldn't speak anymore, many of them.
Andrew Wakefield was not a pediatrician. He's not a psychologist. He was a gastroenterologist at the time.
Okay, so strictly he should be qualified to look at gastrointestinal abnormalities.
Correct.
But the mothers knew that they were suffering pain. And these children would injure themselves, smash their head against the wall. They had violent outbursts against other people. And this was a manifestation of their pain. But doctors had said, all of this is just part of autism, forget it and move on. But it wasn't. It was quite clearly an organic disease until proven otherwise. And it's a golden rule of medicine that you do not ascribe something to a psychological or behavioral origin until you've excluded every other possibility. If you do, then you will not be serving your patients well.
So all of those behaviours that he has described are symptoms of autism.
Yeah, it sounds like it. That sort of self-stimulation and self-injury.
Especially if those children were suffering from a gastro issue.
Yeah.
Whether or not their GPs were negligent in not referring them to a gastroenterologist to have those investigated is irrelevant.
Yeah. I would also imagine that gastrointestinal issues in an infant between the ages of 9 months and 2 years old are not uncommon either.
No, that's right. And their gastrointestinal system is still maturing. As it matures, it becomes more and more able to deal with various types of food.
Right, but kids get sick all the time. You see little kids that are always sick.
That's right. And yes, so these behaviours are consistent with an autistic child whose gastrointestinal system is maturing or experiencing some kind of inflammatory bowel disease.
Yeah.
The children underwent investigation for the purpose of diagnosing the origin of their symptoms, and that's what happened. They had an inflammatory bowel disease. The parents were right, the medical profession had been wrong.
I was almost not going to play this part because it's irrelevant. However, he sets up the beginning of his argument here by saying that the parents were right, the medicine was wrong.
Yeah.
The GPs were probably negligent in their inability to diagnose the gastrointestinal issues that were present, even though the parents were saying that they were. But that doesn't mean that the vaccine was the thing that caused these issues.
That's right. I don't know how it seems like a massive stretch to carry out vaccinations as the cause of these How do you make that link? How is he making that link?
Well, we'll go on.
Okay.
And what was fascinating is that when we treated that inflammatory bowel disease, either with a diet on the parents' recommendation, a gluten casein-free diet principally, or anti-inflammatory medication for the bowel disease, then not only did the bowel disease get better, the symptoms get better of diarrhea and wasting, the children started growing, but the behavioral symptoms got better as well. Now, you could argue that the behavioral symptoms got better because they were out of pain. They just felt better, but there was more to it than that. They started speaking again. They started using words they'd stopped using 3-4 years ago. And that was much more than just a child feeling better.
Well, imagine you're autistic, right? In a high-functioning human brain, you're able to tune out certain inputs, certain stimuli. If you're talking to a person on a packed city street, for example, you're able to tune in just to their conversation and ignore the cars driving past and the people talking and the cars honking their horns and all that sort of stuff. But someone with autism is unable to tune out all of those things and just focus on one thing. So there's a lot of inputs coming in to their system, and it's really hard for them to concentrate on anything and to tune into one particular thing. So imagine you're an autistic child who is unable to concentrate and learn properly, and throw on top of that some gastrointestinal issues that are causing you to feel very uncomfortable, and you can't understand why that is. So your behavior is going to be erratic, and you're going to exhibit the symptoms that he described earlier. Imagine then that you were able to have relief from the inputs that your body is giving you, at least, and only then concentrate on trying to tune out the inputs that are coming from the outside world.
Right, that makes sense. You're removing these internal distractions of pain and irritation.
That's right. You're removing a whole set of distractions that are both painful and unpleasant. Surely your concentration, when I'm sick, I have trouble concentrating on anything. Imagine if I was also autistic and sick. Anyway, so they've had their intestinal issues dealt with, and they're able to function on a different level than they ever have before. Add to that the fact that they're now 3 or 4 years older and have had 3 or 4 years more experience of dealing with the world and trying to tune out different things. Of course they're going to have improved. That's the length of time. It's regression to the mean.
I don't know. It sounds like this Andrew Wakefield guy's a bit of a genius, and he was definitely onto something here.
Let's continue.
So the parents had been right about the bowel disease. The medical profession had been wrong. So when the parents said my child regressed in the face of an MMR vaccine, then we had a very, very clear commitment to investigating that as thoroughly as possible.
So that's a red herring fallacy.
Right.
Saying that because the doctors were wrong about this and the parents were right about this, then maybe the parents were right about this and the doctors were wrong again.
Yeah.
That's like saying because early scientists once thought that you could turn any substance into gold.
Right, alchemy.
And they were wrong about that, then it's possible that Darwin was wrong about evolution. They're two completely different sets of evidence with no bearing on each other.
Okay.
So we decided that after we had seen a number of patients that this should be written up, 12 children, this is so interesting that it should be written up in its own right. And this is called a case series. So the way in which human disease syndromes are first described, be they autism or Asperger's syndrome or Crohn's disease or AIDS, it's usually in a handful of patients who present with signs and symptoms that are so consistent and so unusual that they merit publication in their own right. You make no claims of causation, you can't test hypotheses. All you can do is, this is what the parents tell us, this is what we find, this is what may be going on, more work is needed. And that's exactly what we did.
That's mostly correct. Except instead of doing just that, he then called a press conference where he suggested that the vaccine was the cause for all of these things.
Right.
So he's correct in that in a case series you shouldn't make any suggestions as to what the cause could be, but then his actions didn't follow that.
Yeah, right.
It's interesting in this video that he doesn't mention anything about the fact that the research was later retracted for his fraudulence, or that the 11 co-authors withdrew their support before it was retracted officially, or the fact that the lawyers who represented those 12 children were the ones who funded part of his research.
Right, so this is all happening after, this interview is happening after all that took place.
This interview was published in 2017.
Oh, wow. Okay.
So he still firmly believes that he was in the right.
Wow. Wait, does he actually believe that? I mean, he obviously was doing the research because he was getting paid to do so, but does he believe it?
Well...
Or is there still a monetary benefit for him to be preaching this?
Well, yes, is the answer.
Okay.
He goes on to talk about his movie called Vaxxed and says this.
Because it was the first time ever in the history of this whole movement, certainly in the 25 years that I've been involved in it, that we had an insider, someone coming from the Centers for Disease Control and Prevention, a senior scientist who was involved in designing vaccine safety studies, collecting the data, analyzing the data, writing the papers, coming forward and saying, we have lied. We have found an association, a causal association between measles, mumps, rubella vaccine and autism risk, and we decided not only to cover that up, but destroy the documents so that there would be no record that we had ever found this effect in the first place. Dr. William Thompson, really it's fascinating how one man can change the whole discussion.
So...
Oh, look out, we got a whistleblower.
Classic conspiracy thinking. The whistleblower that he's talking about, Dr. William Thompson, was in fact a scientist at the American Centers for Disease Control, and he was recorded against his will by a friend of his whilst they were having what Thompson described as a scientific disagreement.
Okay.
That's basically all he's said publicly about it, except that he has in the past said that he suffered from paranoid delusions, and that may have contributed to these apparent confessions, in quotes, with this friend of his. However, this conversation was only provided in part, and the quotes were cherry-picked to make it sound like it was a huge cover-up. No documents have ever been released that prove or disprove that there was any sort of cover-up at all.
Okay, classic conspiracy. This is all it is at this
Classic conspiracy theory. Everything was destroyed and there's no evidence because, of course, why would there be any evidence? Everything was destroyed. Yeah, so that's you'll see this running through the rest of the narrative as well. None of the people that we're talking about right now have ever had any legitimate research published currently that hasn't been retracted related to vaccines and autism, except for Thompson, who worked for the Centers for Disease Control and was involved in some research and never found a link.
Okay, so none of these people that we're referring to and none of their work is scientifically credible.
No. Some of their work has been published in the past but retracted, but they currently have no work that is...
Okay, being published and then being retracted is as good as not being published at all.
Correct.
Yeah.
In fact, it's much worse as far as cultural influence goes, but it's telling. Anyway, so his ideas have found a lot of traction in America, and they did especially in the mid-2000s because of the scaremongering around thimerosal, or thimerosal as it's called in the rest of the world. It was suggested that thimerosal in the vaccine was the thing that caused the autism that was allegedly caused by the vaccine. And it's because of the mercury in the thimerosal. So there's a few issues with that. One is just because a compound contains a potentially poisonous substance does not in itself make it poisonous. And in any case, even if it was poisonous, it's all about dosage.
That's right.
Nearly any substance can be poisonous given a high enough dosage.
The solution to pollution is dilution.
Yes. So one of the 7 most toxic substances to human beings is botulinum toxin. Mm-hmm. Have you heard of that before?
Yeah. This is Botox, right?
Yeah. Yep. Also known as Botox that people inject into themselves. So that doesn't kill people.
Well, it can though, right?
It can in the right dosage, yes. it doesn't, because it's not given in dosages high enough to cause any harm.
Okay.
That's just to illustrate that just because there's mercury in thimerosal doesn't mean that the mercury in thimerosal is at a high enough dosage to cause any harm.
Right. Okay. Yeah, this makes sense.
This is a video of Representative Dan Burton, who was a congressman in 2002 in America. He's no longer, but this is to illustrate the arguments that are made by, basically, let's call them conspiracy theorists now.
I have not yet to find any scientist who will say that there's no doubt that the mercury in vaccines does not contribute to autism. Now, they'll say there's no scientific evidence, there's no studies or anything that proves that yet. But turn that around. There are no studies that disprove it either.
So this is what we were talking about last week as well. Proving a negative is impossible. And when scientists say that something is unproven, they don't mean, well, maybe it could be a thing, but we just haven't proved it yet. What they're saying is there's no evidence to possibly suggest that this is a thing.
Yeah, it's really infuriating that the burden of proof falls upon the non-believer.
That's right. And you can't prove a negative. If I said, Levi, why do you go out on the weekends and try and run over dogs with your car? Then you say,
I don't.
And I say, well, prove that you don't. How are you supposed to prove that?
Yeah, prove that I do.
Exactly. It's the burden of proof is on me to prove that you do. Mm-hmm. In this case, there's no evidence whatsoever to suggest that thimerosal or vaccines in general cause autism.
Okay.
Despite all of the arguments for using thimerosal as a preservative, it's no longer used because of this uproar. Whether you think that's a good or a bad thing depends on your perspective.
Right, so there was this thimerosal, this preservative that was perfectly safe to use as a preservative in vaccinations is no longer used just because of public opinion and public pressure?
Yep.
Okay. It's unfortunate that the medical world had to go down that path.
It is unfortunate, but...
And succumb to the pressures of the uneducated.
Yes. Some would say that's fine. It wasn't that important that we kept it anyway, so we have other options. Let's just use the other options and save the argument. Others would say, no, we're kowtowing to the uneducated and we shouldn't let them win. I'm going to reserve my opinion on that one, but a 2012 Cochrane Library Systematic Review. Now, the Cochrane Library is a very good source for systematic review and meta-analysis papers.
Right.
They assess the validity of every scientific paper that they can find and then come up with a conclusion independently of what the issues with the current medical research is and give a plain English summary of the results.
Right, so that does sound like almost the most credible source of meta-analysis, second only to IdioFacto, right?
Of course. Yeah. This is where you come for all the best scientific knowledge.
Absolutely.
As experts in all fields of science.
Every field, yeah. Here we are, answering all the world's questions.
A 2012 Cochrane Library Systematic Review found that we could assess no significant association between the MMR immunisation and the following conditions: autism, asthma, leukemia, hay fever, type 1 diabetes, gait disturbance, Crohn's disease, demyelinating disease, or bacterial or viral infections. The methodological quality of the many included studies made it difficult to generalize their results.
Right, that sounds pretty conclusive. Argument over, right? Like, that's pretty difficult to dispute.
Yep. They did find that vaccine injury is a legitimate concern. However, any medical intervention has potential side effects, and those side effects are weighed up by the benefits. If you go to have a colonoscopy, for example, there is a risk of death in that procedure.
Right.
But the risk is so minimal that the doctor who requests that has taken that into account and decided that it's worth the risk because it's so small.
Okay.
There are some strains of the vaccine that may be associated with aseptic meningitis, febrile convulsion, or thrombocytopenic purpura.
Okay, so these are all proven side effects of vaccinations.
No, I would not say that they are proven.
Ah.
Given that this Cochrane review then also says that research needs to be improved and a standardized definition of adverse events should be adopted. Existing evidence on the safety and effectiveness of an MMR vaccine supports current policies of mass immunization aimed at global measles eradication and in order to reduce morbidity and mortality associated with mumps and rubella. Basically, those conditions that I mentioned earlier can be associated with some strains of the vaccine, but there aren't strong enough links at the moment, and there aren't standardized definitions of those things, and it hasn't been sufficiently studied to draw any proven conclusions.
Okay. But it seems like the anti-vax community is not running with don't vaccinate your kids because it could cause febrile convulsions. They're sticking with the autism card.
It's not quite as catchy. Don't vaccinate your kids or they'll get thrombocytopenic purpura.
Doesn't quite roll off the tongue the same.
I think the reason is because there hasn't been in the last 20 years what appears to be a huge increase in the rate of aseptic meningitis in kids.
Okay.
But there has been seemingly an increase in autism rates.
So do you think this is an increase in autism rates or an increase in autism detection? Or diagnosis?
An interesting question. There has technically been an increase in autism diagnoses. So why? Nobody is actually 100% sure, which is comforting because we're never really 100% sure about anything. There are a couple of proposed explanations. One is that there are potential correlations that need further study between several prenatal factors like parental age, which has been increasing,
right,
obesity level, which has been increasing, diabetes, which has been increasing, and drug use, which may or may not have been decreasing. It's a hard thing to study. Also, potentially related to genetics. Whether that would lead to an increase or a decrease is unproven, but it's a potential explanation if there's an autism gene that is being perpetuated.
So humans are somehow selecting for an increase in the presence of an autism gene?
I think it would be more that humans are not selecting against an autism gene.
Okay. And it's a mutation that doesn't affect our ability to reproduce.
That's right. Having said all of that, it's very likely mostly due to diagnostic changes and better diagnosis of autism.
Right, that makes sense.
A 2006 paper from the journal Pediatrics noted that the decrease in diagnoses in other diagnostic categories, such as mental retardation, has been correlated with an increase in autism diagnosis. So it's basically substitution with other diagnostic categories.
Okay.
All of the factors that I've just mentioned show a much more convincing correlation than a link between vaccines and autism.
Right, but once again, we're running with it. We're running with the vaccine causation.
Well, thankfully, not everyone is. It's a much smaller problem in Australia and the UK than it is in the US.
Right.
And it's almost non-existent in most other countries in the world.
Yeah, I can't imagine this is something that the third world countries get a choice in. You can't be anti-vaccination.
Really. If you have several children dying from measles around you, it's much harder to be against the vaccination.
Exactly.
So that's pretty much it.
Wow.
That was a slog, but
vaccinating yourself and your children is a highly effective means of avoiding disease, right? This is proven.
Absolutely. There's no clear evidence, and like the Cochrane Library says, existing evidence is supportive of the current policies, and it's evidently effective given that we almost eradicated measles from at least Western countries.
Oh, we came so close.
We did. It's really disappointing. But
come on, people, do your own research. Although I think some of this research is dangerous.
Yeah.
Now that the internet exists, it's so easy to get access to so much really, really bad research.
I think that's the message that I'd love to get across if we can do nothing else with this podcast, but get across that doing your own research is really important, but be very careful of the sources of your information.
Yep.
Peer-reviewed journals and places like the Cochrane Library, experts in the field, and not one expert in the field, a consensus of experts in the field, because people who support Andrew Wakefield and his beliefs would say that he is an expert, given that he is a he was a gastroenterologist. He's now been stripped of his ability to practice medicine.
Thank goodness for that.
They would say that he has an expert's view but you need a consensus of experts to make an educated decision.
You do, and it also needs to be accepted by the broader scientific community. I think most importantly, I don't mind giving my opinion on this. I'll continue to get myself vaccinated, and I'll be vaccinating my children.
I'll absolutely be vaccinating my children.
I don't know if I can tell people to go and get their vaccinations or not.
Well, thankfully, it seems like the government, in Australia at least, is so pro-vaccination that they're considering the no jab, no play policy, which is...
Right, this is an awesome thing.
Meaning that you can't go to a public school in Australia if your child is not vaccinated, unless it's for medical reasons. And that's one of the issues with unvaccinated children, basically, because of herd immunity.
But Matt, if my child is not vaccinated and you believe that your child is vaccinated and the vaccination works, why does it matter that my child's not vaccinated?
Well, because my friend's child can't get vaccinated because he was born premature and has suffered a whole lot of other health problems and doesn't have the immune system strong enough to support vaccination.
Right, that's exactly right. And vaccinations aren't 100% effective on every human. Am I right in saying that?
Well, you are, but this measles vaccine, if you get both courses when you're young, it's 96% effective.
Okay, so there's still a little bit of room for error in there, and you'd be hoping that if you were in that 4%, that the rest of the humans are being responsible and doing all they can to eradicate this disease, right?
That's right. Yeah. Yes.
Okay.
Well, you have to be exposed to the disease in the first place, and if the disease is not present in your surroundings, then you're not going to be exposed to it.
Yeah, exactly. Bottom line, go get your jab, people. It could save your life. It's been saving lives for decades.
Get yourself vaccinated. Get your kids vaccinated. Please don't believe pseudoscience.
No, exactly.
Thanks for listening to IdioFacto. Forward all suggestions, hate mail, evidence and arguments to idiofacto@gmail.com.
And you can reach us on Facebook, Instagram, Twitter and all the other socials at IdioFacto. Links are in the show notes.